Okay, this is number 1B. Does the approximation in part A overestimate or underestimate the volume of the tank? Explain your reasoning. On the golden notes, there are several boxes that relate to this. If you look at the golden notes sheet 1 and on the back, you'll notice that if we have a function that is increasing and we are doing a left Riemann sum, then the Riemann sum will be an under approximation. That switches to an over approximation if the function is decreasing. Or if the function is a right Riemann sum, it switches as well. Let's draw a quick picture of that just to review. So if you have a function and the function is increasing, when you do a left Riemann sum, you're picking values of the function that are on the left of each subinterval. And then you're multiplying by the width of the subinterval. So as you do that, you're creating rectangular areas that are less than the ideal. And so if f is increasing, then you know that the left Riemann sum is an underestimate. However, if you were doing a right Riemann sum, you would go to each subinterval, and instead of picking the value on the left of each subinterval, you would pick the value on the right of each subinterval. Then you would multiply by the width of the subinterval, you get an overestimate. So if f is increasing, and you're doing a right Riemann sum, you're going to get an overestimate. And then they alternate if f is decreasing. So it's a pretty easy idea if you just draw a quick picture. If you're doing a trapezoidal sum, what you need to pay attention to is whether the function excuse me, the function you're approximating is an concave up or concave down. So if f is concave down, when you do a trapezoidal, sorry about my throat, you'll cut under the curve. So if f is concave down, the trapezoidal Riemann sum will be an under approximation. If f is concave up, the trapezoidal Riemann sum will be an over approximation. You can write a very simple statement to get the points here. All you need to write is what I have. A is decreasing, so our left Riemann sum is an overestimate. You can see it from the table as well. For this first subinterval, we assumed that the area was always 50.3, when in reality the area was going down. So we're assuming way too much area for the entire 2 feet. Hence, we're getting an overestimate. The red box is 1 point.